Now let's use those ideas that we were just talking about to do example 2. So first off, read the directions for example 2, and you're going to see that we are being asked to solve each inequality and then to graph the solutions on a number line. So let's check out example 2a. First off, you'll need to write down the problem. Negative 7x plus 2 is greater than or equal to 16. So I'm going to start off by thinking about it in terms of an equation. If this was an equation, the first thing I would do is subtract 2 from both sides. We saw just a moment ago that a lot of the ideas from equation world are going to move forward into inequality world. And in particular, subtracting something from both sides of an inequality will lead us to a valid inequality. So let's do it. I'm going to subtract 2 from the left-hand side and subtract 2 from the right-hand side. Over here, the 2's cancel, leaving me a negative 7x. Over here, we have 16 minus 2. That's going to be a 14. Now, the next thing that I would do if I was in equation land would be to divide both sides by negative 7. Well, I'll do the same thing here in the world of inequality land, but I have to remember that idea we were just talking about. Anytime you multiply or divide by a negative number, you have to flip the inequality symbol. So negative 7x, I'm going to divide by negative 7, 14, divide that by negative 7. And because I am flipping the inequality symbol, that greater than is going to flip into a less than. So we're going to have less than or equal to, and that's worth a written reminder. When you divide or multiply by a negative number, you must flip the inequality symbol. So now let's simplify both the left-hand side and the right-hand side. Negative 7 divided by negative 7, that's going to be 1. So we have x less than or equal to 14 divided by negative 7. Positive divided by a negative is going to be a negative, and then 14 divided by 7 is going to be 2. So we have x is less than or equal to negative 2. So now we can take this inequality, which can never be a final answer in this section, and write it using one of our notations we were talking about a moment ago. The interval notation or the set builder notation. I'm going to use set builder notation on this one. It's going to be the set of all x values such that x is less than or equal to negative 2. So there's our final answer in set builder notation. But this particular problem also asked us to draw this on a number line. So I'm going to go up to the top of the board and draw this on a number line. So negative 2 is our important number, so I'll put that negative 2. And because it's x less than, I'm going to color in everything to the left of that negative 2. And once again, notice my arrow was colored in as well. Last item, we have the equal to, which means we're going to include that negative 2. So we need to make sure that we have a solid dot at negative 2. Now that we have that, we're done with part A. Now we're ready to move on to part B. So as you look at part B, once again, let's use some of the ideas we would have used in equation land. I have 3 times a quantity. First thing I would have done in equation land is distribute the 3. I'll do the same thing here in inequality land. Distribute the 3 through, we get 3x plus 3 is greater than 3x plus 4. So now that I have that then, the next thing that I'm going to do is come in and try to get all my x terms together on one side. In order to get all my x terms together on one side, I'm going to subtract 3x from both sides. So subtract 3x, subtract 3x. Left-hand side, they cancel, leaving me with a constant 3. Right-hand side, the x's cancel, leaving me with a constant 4. So at this point then, I have a strange inequality. I have 3 is greater than 4. Now sometimes people will look at this and they will put pieces into this inequality that aren't there. And they'll say, oh, this tells me that x has to be greater than 4. Well, no, there's no x on that left-hand side. Or they'll say that x has to be less than 3. Well, again, there's no x on that right-hand side. So when you get down to an inequality like this, and you notice that there aren't any x's, that you have a constant on the left-hand side and a constant on the right-hand side, you have to be aware of the fact that that means we're going to have to interpret this particular inequality. So 3 is greater than 4. Part of the interpretation is to determine, is that a true statement or not? Once again, if you draw this on a number line, this is asking, is 3 to the right of 4 on a number line? The answer is no on that one. So I'm going to start by just making the comment, This is never true. So the question then becomes, how can I write this information down as a solution set? So my solution set, I want to write down the fact that nobody lives here. And a nice way of doing that is to use a very special symbol. And the symbol is called the empty set symbol. So I'm going to first of all write down the symbol. It's a circle, and then you have a slash through it. And that, once again, is called the empty set symbol. So my answer as a solution set would be the empty set symbol. So I'll underline it to say that that is my final answer. So now the question is, what would that look like on a number line? The answer is, it's already there. So if you look at the number line on your piece of paper, it's an empty number line. It's still going to be an empty number line when we're done with this because this is the empty set. There's nothing that you draw on that number line because no x value actually makes this inequality true. So one more time, you can't stop at 3 is greater than 4. You have to interpret what that inequality is telling you. And again, in this case, that means that we have the answer, which is the empty set.